So in this video, I'm going to try and kind of go through the methods that I use to try and ensure that students understand the principle of equilibrium. So this is a PowerPoint that I've used with classes, and I'm going to explain why and how I've used it. So firstly, I've tried to remind them of the principle and try to use the right language, because we know that when you are doing Le Chatelier's principle, the mark scheme is always in the same format with the same language. So teaching children that language correctly the first time. I've decided to use the Haber process to do this, but you might decide on using ammonium chloride, for example, because that's one of the other curriculum ones that they need to know. You've also got the hydrated copper sulfate and anhydrous copper sulfate reaction that they also need to know. So you could use any of those three. I chose the Haber process because it's the one they are most likely to see. So I've given them a think question, the factors that can change dynamic equilibrium. So we've talked about equilibrium before. I'm not introducing it for the first time. This is me checking and modelling the concept, because it is a difficult concept for students to understand. So reminding them that pressure, temperature and concentration are the only ones we need to remember for this. Also reminding them that they will affect rate of reaction. So the reason they affect equilibrium is because they affect rate of reaction. Moving on, I'm going to walk them through what happens as I go through. So I've got my equation. I'm going to ask a child, I'm going to say, what would you like to change the concentration of? So let's say they say they'd like to change the concentration of the hydrogen, and I'd ask them if they want to increase it or decrease it. Most of the time they pick increase, which is what I want them to do because it helps with our visuals. So I tell them they need to physically put an increase arrow underneath the thing that they are increasing the concentration of, and that arrow is going to continue in the direction that the reaction is going to go. So we would talk about the idea that if I increase the concentration of hydrogen, I'm going to shift the reaction right to minimize the change. So I've tried to make it really clear to the children the language they need to use, and I've given them a visual of what that looks like, and I tell them that I expect them to draw that on their papers. I'm then going to do the same thing with temperature. So I'm going to ask them where the heat is. If the forward reaction is exothermic, where's the heat? And we're going to visually put the heat into the reaction. So again, I ask them, if I increase the heat, what direction is it going to go? And we're going to visually see it go around. At this point, I'm probably going to explain that if you were to cool it down, we're going to do the opposite. So always work out for increasing, and then if you're decreasing, do the opposite. Lastly, we're going to talk about pressure. So that's my equation. So if I'm going to talk about pressure, we need to talk about the idea of molecules and how many molecules on each side. So the students should be able to identify that there are 4 molecules on the left and there are 2 molecules on the right. So they would like to spread, they would like to be 3 and 3. It's at equilibrium. So if I increase the pressure, I'm going to push those 4 molecules to spread over and head right. And again, I'm going to talk about shifting right, minimizing the change. I would then find a past paper question. So take this one, for example, and I would model it for them. So I'm not going to get them to now just go into a question. I'm going to look at this question. I'm going to talk them through my metacognition. I'm going to talk them through my thinking. So I'm going to say, in industry, methanol is produced by reacting carbon monoxide with hydrogen. The equation is here. I can see that it's reversible. A pressure of 100 atmospheres is used. So pressure is important. Instead of atmospheric pressure, the higher pressure gives a greater yield and an increased rate. And I'm being asked why. So why does that happen? Well, it's pressure. So I need to think about my molecules. So I've got 3 versus 1. So there are fewer molecules on the right. So the reaction shifts right, increasing the yield. And then I need to look at the fact that they also talk about increased rate. Why does this happen? More molecules on the left means more collisions, therefore more successful collisions. We would then look at the mark scheme and we'd mark that together, and then I would have more examples for them to do. And that's when I would leave them, although I would remind them that I would expect them to write this equation in their books so that they can then add their arrows to show what direction things are going to go in dependent on the question. So I'd want them to visually show that in their books so I can see that they're getting that right way around. I hope you found that helpful. Thanks very much.